find the antiderivative of the product of the tangent and the square root of the secant, what you want to do, you want to write the tangent as sine x divided by the cosine of x multiplied by the square root of 1 over cosine of x dx, right? Because you know that the secant is 1 over cosine, right? So inside the root you're going to have 1 over cosine. So now look what happens. What happens is that we get sine x, and then square root of 1 is just 1, right? So we can disregard the square root of 1 being on the top and just leave it as sine x. But on the bottom we're going to have cosine of x times the cosine of 1/2 x dx, right? Because the square root of cosine is the same thing as writing cosine of 1/2 x, right? Cosine of x raised to the power of 1/2. Right, so now you can combine the cosines using the powers, the power addition, right? So you're going to have sine x divided by the cosine, and the net power will be 2 over 2 plus 1 over 2, which gives you 3 over 2x dx. So now this should be easy using the U substitution. U is going to be cosine, right? Du is going to be what? Is going to be exactly minus sine x dx. Right, so there's no minus, so we're going to have to have a minus because the negative du is exactly sine x dx, right? So the minus will go outside, right? So we're going to have minus as a result 1 over u to the 3/2 du. So we can write it as minus u to the negative 3 over 2 du, right? Because the u to the 3/2 is in the denominator, right? So we can express this as without the fraction, and we need to express it without the fraction so that we can use the power rule of the antiderivative, right? So now what is going to happen? The power will increase by 1. Negative 3/2 plus 2 over 2. 2 over 2 is 1, right? So negative 3 over 2 plus 2 over 2 is negative 1/2, right? So that's going to be the net power. Right, and also you will divide by negative 1/2, right? So we'll get negative 1 over negative 1/2 u to the negative 1/2, that's the net power, plus a constant. So two negatives get cancelled out, the 2 goes on the top, right? So as a result, what happens? We get 2 over u to the 1/2. Well, let's express it as a square root, right? U to the negative 1/2 means 1 over u to the 1/2. U to the 1/2 is square root of u, right? Plus a constant. So expressing u in terms of x, u was cosine, right? So 2 over square root of cosine. 2 over square root of cosine x plus a constant. But you know what? I don't like this fraction. You know that the 1 over square root of cosine is what? Is the square root of secant, right? That's the square root of secant. And you know, I'd like to keep the square root of secant because we had a square root of secant in the beginning in the original integrand, right? So let's express it that way. 2 square root secant x plus a constant, right? So this is going to be your correct antiderivative. And keep in mind, this 2 is outside. It multiplies the square root. It's not the it's not the number applying to the root itself, right? It's already a square root, right? I would not write a 2 that would suggest it's a square root and not a cube root or a fourth root, etc., etc., right? The 2 multiplies, right? There are 2 square root secant x's basically, right? 2 times square root of secant x plus a constant. Thank you so much for watching. I hope this was a lot of fun, and I'll see you in the next videos.